Hey guys, Acto here and welcome to Normal Probability. This is what it will look like. We'll have a screen that will say Z and then some expression involving the Z, which will be referring to a standard normal distribution represented by phi of Z. And the probability will describe is big Z, which is always going to be big Z, and then little z, will be replaced with a number. We're not going to be using calculators for this, we're going to instead use this table. So, the first stage here is quite simple. Since we have one or two decimal places, we're just going to find the intersection between the 1/10th part and the 100th part and just type that in. And since it's in the form of big Z minus, it's less than something, we could just read it straight from the table. So we have 1.6 and 0.06. So our first answer is 9515. Up next we have this. So this is where we get a negative number, but we still have a less than here. So this will require some manipulation to figure out how to solve this. So Z being less than negative 0.482, if you see the graph, it's symmetrical around 0. So we can use that fact to make stuff positive. Basically meaning that our value Z being less than the negative number is the same as our value of Z, a different value of Z being greater than the positive version. So we're rather going to find, so Z being less than this one is the same as being greater than the positive version. But of course now we have a greater than sign, so what do we do now? In this case we just take 1 minus and then flip around the inequality sign again. So when we get given this, we're actually going to be calculating this. So let's find a number like normal. So 0.482. This is where we need this add column. With the add column, all we basically do is multiply the number we get from this column by 0.0001 to get the extra little bit we need to add on to it. So our initial number is 6844, 0.6844, but we're going to be adding 0.0001 times 7 to it. So our actual value is this, and then remember we're now subtracting this from 1. So 1 minus this, we get 3149. And if you think about it, this makes sense. We're expecting a number less than 0.5, so this makes sense. And if we press submit, we move on to the next stage. And this is where the slightly more difficult part comes in. In this case, we might have to visualize the graph a bit more to figure out what we have to end up doing. So this right hand side is easy. We could just do as if the left hand side isn't there. So 0.818, we have 0.7910, and then we're going to be adding 0.0001 times 22. So we get this. Keep hold of this number, because of course we now have a lower bound as well. So in this case, what we calculated here is going from 0.818 and going completely to the left. So of course, to get it in between, we should take the other side of it, take that to the left, and then subtract that off of it. So in this case, we're going to take z being less than this value rather than greater than it, and then subtracting that value. So the probability of z being less than, if effectively we're basically swapping these round, that's a sloppy way of saying it, but we're effectively now calculating z is less than 0.8586, so 0.586, we get wait, did I do this wrong? No, I didn't. It's just I got a little worried there, but the same number appeared in both these places. Oh, it's not even the same number. I can read it. So, not 0.7190. Apologies for that. That's for the 0.58 part. Then the extra 6 part, we're adding 0.0001 times 21. We get this value. And then we subtract these two values. And we get 0.0721. And hopefully if we've done this right, we get self-module. Let's do another example. First stage, pretty simple. Just reading out of a table. 2.29, 2.20, 0.09. We get 9890. In this case, we have less than again. There's a chance that you can get a greater than sign appearing here. If you get a greater than sign and a negative number, you can just pretend that it's just a normal question. You can just do z is greater than the positive version. If z is less than the positive version, yeah. I think you can do that. Because, say this z is greater than negative 1.725, you would first try and get rid of the negative by taking 1 minus. Or you first flip the sign, I think this would do. So less than that. And then for this part of it, z being less than that number is the same as it being greater than the positive version. Which then we got greater than again, so we take 1 minus the complement of that. As you can see, these then flips the inside of this, and the ones will cancel out, which you then get being less than the positive version. And in the case of it being greater than, you just take it being less than it and then subtracting it from 1. But in this case, we have it less than the negative. So for this, we're just going to it being less than the negative is the same as it being greater than the positive. Z being greater than the positive version, which we then have to take the complement of. So we could be calculating this. So 1.725. Yes, 1.725. We get 0.9573, and we're adding the extra part, which has value of 4 here, which we get this value. But of course, that is less than it, so we then have to subtract it. So we get 0.0423, and then we get this part again. I don't think we had a negative number on this side, so again, this might rack your brain a little bit to figure out what we have to do. The right hand side is generally always the same though, unless you get a negative number. Then it might require a bit more manipulation first. But this one, the right hand side is just a simple question. 0.625. We have 0.7324 plus 0.0001 times 16. And we get this as our first number. Then it's over the second half. We're going to be dealing with z being greater than negative 0.419. So let me just go through the working again. So first of all, let's get rid of the greater than sign, less than, and subtract it from 1. And then z being less than the negative would be the same as if we flip the entire thing, so z being greater than the positive version. So that becomes positive, and the sign flips again. We have a greater than sign again, so let's subtract it from 1 again, so we can flip the sign again. And then again, the ones here will cancel out, so we can just calculate this value instead. So 0.419, we get 0.6591 plus 0.0001 times 32 this time. We get this value. So this is the value of it being greater than, actually yeah, so technically we could have just done what we did last time and flipped it round from the beginning, z being less than this negative value, because since we have this now, this is actually the opposite half of what we need, because we, like last time, want to subtract off that bit. If in the off chance you do make that mistake though, thankfully all you have to do is subtract this part from 1. So we now have this, just to show you that it would have worked the same. It being less than this, z being less than the negative, like I said a few times now, being less than the negative, same as being greater than the positive. And then, as you can see, here we then have 1 minus this to flip the sign round again. So again, this is the value we calculated just now. but we need 1 minus that value. So if you calculate the wrong side, you can just subtract it from -1, not -1, from +1. So now, doing this calculation, we get 0.3963, which in a sanity check, I think that looks right. And it was. Sorry if that was like a bit higgledy-piggledy at the end there. Let me just re-explain that last one again. So, the first part was normal, but what we started with was this. And like the first example, the easier method to do this is if we want to get in between two values, we just take the less than from the higher bound and then subtract off anything lower than the lower bound. So in this case, we can just ignore it being two conjoined functions and just finding what this value is. But okay, the less than version. But then of course we don't have negative numbers, so we then manipulate it. Where in this case, like I said a few times, less than negative, same as greater than positive. And then we use the trick of taking the complement of it if it's greater than to make it a less than, but we also have to subtract it from 1. So we subtract it from 1, we flip the sign around. So this is what we get. Calculating this, we get these values, which we got as this one. We got as this, which we then put in here, which gave us the 3377 that we used later on. Hence why if you naively started by just doing this the other way around, if you like do a sanity check on it and think the number's going to be too small, just subtract that from -1 if you realise you made that mistake. Subtract it from 1 even. Okay, so hopefully you now understand how the normal probability module works now. Sorry it was a bit messy. I don't know why it was messy, but hopefully you still understand how it works. And I'll see you guys in the next tutorial. I'll see you later.